Hi guys, today we're going to be going over the triangles problem in USACO 2020, February contest bronze. So in this problem, Farmer John would like to create a triangular pasture for his cows. And there are n fence posts, and n is always going to be in this constraint. And those fence posts will be at distinct points x1, y1, all the way through xn, yn on the 2D map of his farm. And he can choose three of them to form the vertices of the triangular pasture as long as one of the sides of the triangle is parallel to the x-axis and another side is parallel to the y-axis. What is the maximum area of a pasture that Farmer John can form? It is guaranteed that at least one valid triangular pasture exists. And so the input is basically going to be, the first line of the input is n, and the next n lines contains two integers xi and yi, each in the range of -10 to the power 4 to 10 to the power 4 inclusive, depending on the describing the location of a fence post. For the output, as the area itself is not necessarily an integer, I'll put 2 times the maximum area of a valid triangle formed by the fence posts. So basically, the area of a triangle is sometimes it might be like 0.5 or like 1.5. So we're gonna have to output the area as a um, 2 times the actual output. Okay, so for our sample input here, we get n, and then we get n fence posts, so it's gonna be 4. So of our 4 fence posts, the maximum area is 1. So we're gonna multiply that by 2 and output 2. And basically this means that there are posts at 0, 0, 1, 0, and 1, 2 that form a triangle of area 1. So the answer is this, and there is only one other triangle with area 0.5. Okay, so now let's go ahead and try to visualize the points. I'm going to be using Desmos. Okay guys, so as you can see, I've listed out the points that make the biggest triangle, and I'm not sure if you guys remember reading it in the problem statement, but basically, in the problem statement, it says that Farmer John needs to choose three of the points to form vertices of the triangular pasture, and he needs to make sure that one of the triangle sides is parallel to the x-axis, and one of the triangle sides is parallel to the y-axis. So they need to be parallel to the x and y axis, and we can see that that works here. This is parallel to the x-axis, and this is parallel to the y-axis. So in other words, we need to find a right triangle, because if we're going to have one side parallel to the x-axis and one side parallel to the y-axis, no matter how you see it, it's basically just going to be a square with one point missing. So, or a rectangle. So basically, what I've done here is I've listed out the 3 points, the 3 x coordinates are from each of the points, and these are the y coordinates. And so basically there's a similarity between these. So there are 2 x coordinates that are the same, and there are 2 y coordinates that are the same. So in other words, basically we have these 3 points, right? And we need to make sure that of these 3 points, there are 2 points that share the same x coordinate and 2 points that share the same y coordinate. Or else we're not going to have a triangle, and we're not going to have a triangle that meets this criteria. So let's look at an example of a triangle that does not follow the parallel to the x-axis and y-axis criteria. So this is also one of the triangles that is possible from the 4 points that were given. However, you can obviously see that there is no side length that is parallel to the x-axis. And obviously, since we adjusted the y-coordinates here, we would need to adjust the y-coordinates in our list as well. So you can see that now there are no longer 2 y-coordinates that are the same. And so this is not going to pass our test. Now, let's say that it's back to normal. But now let's test for a case that isn't a triangle. So for example, let's move this to 2, 0. So this is a line, right? This is not a triangle. And now we need to fix our x coordinates and our y coordinate list. So now our x coordinates, there are no two x coordinates that are the same. However, we have three y coordinates that are still the same. So now we know that we need to check that both the x coordinates and the y coordinates have to have two in common, no less, not less than, not greater than, right? Just two for both of them. So that's the criteria we need to meet, and now we can move on to the programming section. Okay, so we have our standard um, buffer reader and print writer here, and then we have our static variables here. So we're going to have n, and we're also going to have a 2D array called nums, which we're going to store our points in. And then we have um, two tree sets, which is going to be x and y, and these are going to store our coordinates later. So here we have our in, out, and then we call our methods, and then we close both of these. And then in our initialize method, all we're going to do is just set up the nums array, and then we're going to start putting in the points into the array. So basically the first column is going to be the x coordinates and the second column is going to be the y coordinates. And then in our solve method, we have a int called array area, and this is going to be our where our answer is going to be stored. So basically here we have a three nested for loops, which is going to test every single type of combination that we can make with um, the points that we're given. So it's going to take all the x's and then test them with all the y's. And then what we're going to do is once we have a point, or I guess once we have 3 points, we're going to check them. So we have a method called check, and then we're going to run them through the method. And so basically, what the method does is it takes in three arrays and it makes initializes the two tree sets that we have here. And then what we're going to do is add all the x values to the first one and the y values to the second one. And remember how we had to check and make sure that all the x coordinates have two in common and the y coordinates have two in common. That's what it's doing here. So it's just making sure we have two x coordinates in common and two y coordinates in common, no less than and no more than. And then if that happens, oh yeah, just one thing. If you don't know what a tree set is, all you have to know is that it doesn't allow duplicates and it's constantly sorting its elements to be in ascending order. So basically here, we're adding three, but it's going to remove any duplicates. So we're going to only have two because it's going to be only two distinct values. And then same here. And then we're going to use the second principle that I talked about how it's going to be sorted into ascending order. So we currently have area at whatever it was at before, and then area is now going to be equal to math.max. So whichever one is greater between two elements. So the first one is the array variable in its initial state, and then the second element we're testing is x dot last minus x dot first times y dot last minus y dot first. So what we do here is we're using the principle that they're in ascending order. And what we're going to do is we're going to just take the, I guess, the length of the line that runs parallel, or length of the side that runs parallel to the x-axis. And so x dot last minus x dot first is just going to take the last element of the tree set, which is the greatest one, and then the first element, which is the smallest one, and then it's going to just find the length between those, and then it's going to multiply it by y dot last minus y dot first, which does the same thing just for the y axis. And um, now you might be wondering why we're doing this, but just remember that when we output the area of the triangle, we're outputting it multiplied by 2. So we don't have to do any like divide by 2 and then output area times 2. We'll just leave it like this. So basically, we're just getting the area of the rectangle that we're given with the side lengths, right? We're finding the area of the rectangle, and we just output the area of the rectangle because remember, a triangle is always two rectangles. So yeah, we output the area here, and now we are ready to submit. So as you can see, we pass all the test cases, um, and so that's the triangles problem. If you have any questions, please feel free to leave them in the comments, and thank you for watching.